Hi everybody, I'm Inga, and today I'll be presenting PRISM, a programmable RNA for immune state modulation program. Immune diseases are a global unmet need. Every single year, 6 million new cases are diagnosed, and globally, 400 million individuals live on a day-to-day basis with an immune disease. Diseases such as rheumatoid arthritis, asthma, celiac disease, ulcerative colitis, and multiple sclerosis cause suffering and pain that does not have solutions to it. If we take the biological example of diabetes type 1, we can start to look at the biology of what is happening. Inside of diabetes type 1, beta cells live in these islets inside of the pancreas. If attacked by a T cell, they get the signal to self-destruct. Current treatments include insulin, islet transplants, or monoclonal antibodies. Yet insulin treats the symptoms, not the root cause. Likewise, islet transplants cause permanent immune risk and immunosuppressants to be taken for the rest of your life. And monoclonal antibodies are single target, meaning they only solve one single part of the problem, but not the entire solution. They're also very expensive. The ideal therapy, what does it look like? The ideal therapy is a multiplex, conditional, and deliverable therapy. Multiplex, because you can start to regulate the cell in a very specific manner based on the RNA present. Conditional, because you want to activate or change or modulate the self-destruct signal and bring it back to a physiologically balanced state. And deliverable, because you want to target only that beta cell that is being driven into a self-destruct state, not all the other cells. Immune diseases are an underserved space. They're chronic and multi-node, meaning they act across multiple cell types, across multiple organs inside of the body. They also cause persistent tissue damage. Current treatments are one target, one disease, meaning they treat symptoms, not the root cause, and ignore system-level dynamics. Current problems include off-target effects, immunosuppression when immunosuppressants are used, and incomplete remission, leading to even more pain and persistent tissue damage. So what if we could design RNA therapeutics that mimic how the body regulates the immune system? Here I introduce PRISM, a programmable RNA for immune state modulation program. The aim of the program is to design RNA therapeutics that deliver multiple modes of action in a conditional manner whilst incorporated into a single delivery vehicle. If we look at the VC funding landscape and the wider landscape of funding today, we can see that most of the funding goes into single assets. Here we see along the diagonal, for example, siRNA, mRNA, ASOs, yet not many people are venturing out into the multi-target RNA landscape due to unproven technologies. It doesn't mean they're impossible. Furthermore, inside the body does not distinguish between siRNA, mRNA, or ASO. They're all happening at the same time and downregulating and upregulating one another. If we look at academia, we see there is more exploration of these multi-target complex systems. For example, divalent siRNA scaffolds, trans-amplifying RNA systems, and even RNA origami systems. What we see here is that each grid point is a potential convergence, an unmet potential. What PRISM aims to do is translate these technologies and make them more accessible to patients faster, bridging that unproven technology gap that currently exists. The program will be divided into 3 different years. Year 1, LEAP, Year 2, Advance, and Year 3, Translate. In Year 1, 8 to 12 teams will be selected to receive $750K each. With this funding, they will achieve the first milestone and show that 2 RNAs can be co-delivered in a single cell or delivery system. After that first year, 2 to 4 teams will go on to receive $3 million each to be spent over the course of 2 years to hit the second milestone of state-specific in vivo activation confirmed, with a CMC plan and pre-IND work completed. At the end of the second milestone, 1 to 2 teams will go on to receive $5 million each, acting as a launch grant to translate technologies. PRISM unlocks a new therapeutic category of multiplex biology-regulating RNA treatments. If we look at the current way that RNA therapies are done, we see that we have chemists, biologists, machine learning engineers all working on the problem, yet they're all working separate. Chemists are focused on siRNA backbone optimization, biologists are focused on cells talking to one another, and machine learning engineers are focused on sequence optimization at scale. What PRISM aims to do in 3 years is to bring together these different chemists, biologists, and machine learning engineers into a single program to really talk to one another as the body does. The outcome? Achieving in vivo validation of state-specific activation inside of cells, with 50% higher efficacy relative to separate dose controls, and achieve a technology readiness level of 4 to 5, having pre-IND work complete and being ready for IND translation and follow-on funding. If PRISM succeeds, an entirely new way of treating complex diseases will exist for 400 million people globally. Thank you. I also want to say ideating program takes a network of people. If you're interested in learning more, this is my huge mind map, which I will go happily talk you through into what I've been thinking about.